Hi, everybody. Oh, hi, everybody. This is Dr. Schulman. We're jumping into geometry. Geometry is probably like one of my favorite topics to teach, probably because students can touch it, they can hold it, they can feel it. So the more actual elements you bring in will be the best. I've so it's six, seven, and eight in the licensure exam, but there's tons of geometry. So six is actually broken up into G parts. We're gonna start with the first one. This first one is nothing too crazy unless you feel like it is. So it's basically we're measuring one, two, and three-dimensional figures, strategies for using standard and non-standard tools, and appropriate units for length, area, perimeter, surface area, and volume. We're probably not going to cover every single little piece of this, but guess what? We will throughout it because that's just A, and I wanted to kind of break it up so it wasn't too overwhelming to hit it all in the beginning. Now, there's naming, there's comparing figures, there's so much here. We go all the way for decomposing and manipulating them. Now, one of the best things you can do for your students is to actually give them stuff, or you can use like an online version like Polypad. It's by Mathagon, and online it's an online manipulative. So whether you want to use like actual physical balls and cylinders and triangles, have students go out and find them, or however you'd like. Measuring this stuff is really useful. So we're going to jump right into it. I'm going to share my screen, and hopefully this is really clear for us. I'm going to use delta. This is all going to be in its own delta, so I might as well put the code at the top of this one because this is the first one where you get to have, it's just for geometry, so you get your own delta set, which should be cool. So let me do that first before I jump directly in. We want to go to tools. So this was the class that I just made. And here's the code. This the code I'll put at the top. All the other ones are in both. Oops. We're all on the same page. There's your code to get in, which is nice. Bring it right in there. I should also give you Polypad. I know I did another video, but in case you didn't do the technology one, Mathagon, Polypad. This thing is awesome. I like giving students handheld stuff, but sometimes you don't want to bring everything in. So Polypad's awesome. Any sort of shape you can build. You can build shapes together. We can rotate shapes so they kind of like click into each other. Boom. And we can like actually, how many do I need for this? It's one, two, three, four, five, six, seven. Is it seven? One, two, three, four, five, six, seven. So it's a heptagon or a septagon. Three, four, uh, five, six, seven. I think it'll close. So what happens if I highlight them all? Can I close this thing? And then I can rotate it. Oh, I didn't do it right. So I didn't make it right. But here I'll do it better for you guys. Here, let me actually build this correctly. So we need two of them. We need a top and a bottom. And how many sides is this? It does a cool song too. Three, four, five, six. So I need six. So what I'm making right now is a hexagonal. It's a hexagonal prism. Why is it called a prism? Is because it has a flat top and a flat bottom. Three, four. It's gonna look like a little hammer. Sorry if it looks a little phallic. One, two, three, four, five, six. My bad. But at least you can see. Let's fold that thing. Whoa, wild. All right, I want to fold it. Oh, because they're not exactly lined up. That's why I didn't want to fold. Let's fold the net. And I just made it. Isn't that awesome? Right? You could put a coordinate plane behind it. you want, you can unfold that thing and really show students how to work with it, which is great. Another good thing about this stuff is you can cut them. So let's say we just wanted to cut it, or let's just put a new shape on. Let's say you just wanted to have a student cut. You can cut any part of this thing. And now I got a piece that I can move. So there's all these other things. You got tanagrams and 3D solids, fun stuff. You don't want to make it yourself. Woo! So yeah, I hope that's kind of cool. Just something to show your students, you know. All right. So that was a little bit of intro. I've got tons of units and lessons and stuff like that, but I just thought might as well show you some cool things. The difference between a prism and a pyramid is really important for students. Notice that prisms, these are made of triangles. Whoa! And they're always named by the base. So that's 1, 2, 3, 4, 5, 6. So that's a hexagonal pyramid. So it has a point, and this is a prism because it's flat. Flat on top, flat on bottom. So just something really simple, but let's look at some problems. You can show students how to measure things with rope. I really like lessons where you get to use like tape measures and ropes and students can measure themselves. I have got tons of lessons like that, like students could measure themselves, like if they were the pharaoh. I'm sure you saw that in one of the ones that you maybe not. I don't know. Maybe you'll see it later when we do the project-based ones, or if you want that one, students measure themselves like the pharaoh, and then they get to dilate it in huge images, and they get to see like how how proportional their body parts are, which is cool. Other things that they can do is other really cool lessons. There's a great kite lesson. There's all these really cool things. I have a cool lesson where students figure out pi by measuring different pots and pans with string. But I think all this stuff is really useful and really important. But I just thought I'd throw out just some choices, just some ideas before we jump into it. So here we go. Here's 6A. A good way to do this is we've got one dimension. So a point has no dimensions. A line segment. Here's a line segment. That's 1D. So there's your point. There's your line. 2 dimensions is like a square. It's flat. So that's 2D. And 3D is a cube. So basically in math, we can go as many dimensions as we want. In other sciences, they build this by here, 0 centimeters, 4 centimeters squared, 16 centimeters. Oh, sorry, just 4 centimeters because there's nothing here. 4 centimeters, 16 centimeters squared, or 64 centimeters cubed, just building up by the dimensions. Sorry, I'm talking kind of fast and there's a whole lot here, but I just thought it'd be interesting for you guys to see. So I did all the geometry ones except for 8B. There was no time on here, so I just gave you a worksheet. So let's jump into 6A. Here's the first one, and let's learn some skills. There's not a ton in this one, but I just thought it'd be a really simple way to get started, just doing some measurement. So here we go. So here's an area. All of the quadrilaterals in the shape below are squares. Find the area of the shaded region. So basically it's kind of covering up this piece, right? So here we're going to start with this one. And a quadrilateral just means it has 4 sides. That's all it is. And for each of these, we can figure it out. So if I have the whole one, and we have this piece, which is an 11 by 11, which is 121. Then I have this piece, which is 7 by 7, which is 49. And you see how this one's kind of like overshadowing it, but this box looks like it matches right on top of this box. I kind of feel like they're the same. So I'm going to guess that the whole region, well, we could do the whole thing if we want. 11 times 7 is to get it. Is to be 77. And let me just pause this for a second. I'm just gonna pause the video for 1 moment. All right, sorry about that. Let me go right back into sharing my screen. So there's a few ways we can do this one, nothing too crazy about it, but we can think about it as 11 times 7 So this is 18 by 18, but I see that this box is just the same as this one. So if we want to think of it as the whole piece is 18 by 18. And if you're worried about multiplying, if you think you might get it wrong, that's okay. We can just do 18 times 18. So I know the whole thing is 324. Nothing crazy about that. Now we have two of these that match. So I have one of these here, one of these here. So I know these 49s are going to get taken out of it, but because 7 times 7 is 49. But I just see that this piece looks like a perfect match for this one. So I'm actually going to go with the 121. Oh, oh, so we did have to do that. Okay, what a good problem. So you do have to subtract it. So let's try another one of these. What a great way to start a nice challenging problem. So we have to take out this box, and this box from the whole thing. So I know that this is 9 times 7. This is 9 times 7. So it's going to be 63 times 63. So I know the whole, wait. I just messed it up. Okay, so it's 9 plus 7 and 9 plus 7. So it's 16 times 16, which is 256. So the whole thing's 256. I got to take out a 7 by 7, a 7 by 7, and a 9 by 9. So the 7 by 7s are both going to be 49s, and the 9 by 9 is going to be 81. So all I have to do is do 49 plus 49 plus 81. So, and I have to subtract that from 250, not, wait, shouldn't it be 256? 16 times 16, it is 256. I don't know why I wrote a 9 there. So it's 256 minus 49 minus 49 minus 81. So our answer should be 77. What a great problem to start with. Nice. What a great area problem. So basically for any area of a box, it's always going to be length times width or base times height. So as long as it makes the right angle, you'll always have it. If it's a triangle, it's like half of this, so it's going to be base times height divided by 2. But basically for any area, you always just want to look for a right angle. Let's see what else we got. Okay, so drag the yellow point. So we want to get the right, there's the right angle to get it. So the length of the base is this whole thing, which is 6.6. The height is 3.77. So we just have to multiply them together. 6.6 times 3.77. Because a box is usually base times height or length times width, but if we cut it in half, you can see that it turns into a triangle. So the form is 1/2 base times height, which is 12.441. Ta-da! Beautiful. Oh, cool. I like that it's spun. That's pretty cool. Let's do another one. Area triangles. All right, here they just give us the base times the height. So it's 1/2 times 10 times 6.5. Half of 10 is 5, so it's 5 times 6.5. We can do 65 times 5, which is 5 carried by 2. 32. We move the decimal because there was one decimal in the question, one decimal in the answer. Notice that the units are squared because we're talking in area. So now we have a composite shape, which is kind of cool. So for this composite shape, I'll just go over here. What is the area below? So we can do the whole thing minus the box. We can cut this however we want. For a trapezoid, it's 1/2 height base 1 plus base 2. That's the formula for area of a trapezoid. Just so you know what it is. So if you have a trapezoid, you take base 1, base 2, you add them up, take the height, you cut it in half. However, we can see that this is just a triangle. So we can do the box minus the triangle, and we're left with the shape that we want. Ta-da. So that's the way that I would recommend doing it. We know that this is base times height, or 12 times 16. I do it in my head, but I can just show you this way. 12 times 16, 192. Remember, this is 1/2 base times height. The base, okay, so we know this is 12, so I got my height is 12. 1/2 times 12, and what is my base? Well, this is 16, and this is 10, so what's left over? It's got to be 6. So half of 6 is 3. 3 times 12 is 36. So we just subtract the two pieces, and that's how we get the composite shape. These problems come up all the time. Oops. 156 is the answer. So just take your time, try your best, and you'll get the right answer. Ta-da! Oh, they did the whole thing minus the triangle, which is cool. They didn't use this formula. If you use this formula, you'll get the same thing. I'll show you. So this is 0.5 times the height, which is 12, times, and we just need parentheses, base 1, which is 16, base 2 is 10. Ta-da! Same exact answer, 156. So whether you use the trapezoid formula, which most people don't remember, I would just recommend you just cutting the shape. All right, so perimeter, we just add up all the sides. We add up all the sides and we get it. Check the perimeter. When they say perimeter, the best way to think about it is just side plus side, dot, 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 dot. So we just have to add up all these little sides. But since these are all the same, 1, 2, 3, 4, 5, 6, 6 of them are the same. So I could just do 6 times 4.1. Then I can add 2.3 plus 2.3. Notice that the units here, since we're going around the shape, are just meters. If it's the inside, the area, the whole space, it's square units. That's why it's just meters here. Ta-da! Ooh, they did it that way too, instead of just adding them all. All right, so let's do one algebraically. So we don't have any letters, but we can just figure this out. I have 2 H's plus, I have two I's plus, I have 2 J's plus, I have 1, 2, 3, 4 K's. I think that's all my letters. H, I, J, K. Yeah, should be good. What? 2H, 2I, 2K. Oh, I forgot the J's. I was do a new one. All right, so I have 1, 2, 3 P's. Let's not forget one. Plus 2 R's. Plus 1 S. Plus 1 N. Plus 1 Q. That's a lot of letters. I hope I didn't forget any this time. Nope, that's them all. So you could have written it all out or with the algebraic, just the letters. All right, so volume is when we're going 3D. So if we're doing 3D, we have play. How many cubes fill that? We got 3 of them. how many cubes? So it's 3 times 9, which is 27. And we're just watching it fill up. And now it's the whole thing, which is 9 times 3 times 7. I like this idea. Oops, I like this idea of them showing the entire thing fill up. 189. I mean, this is a really good way to show students this, how it's like the air getting filled inside of it. But I'm gonna pause this one. I think it's a good start, a good place to start and stop. I'll be making the rest of this and the rest of them, but I just thought I should do it. And if you have any questions, just feel free to reach out. We're stopping at just the volume of a rectangular prism, and I'll just make a part 2 to this video. Have a great day.